Little quick video on Phi and Fibonacci. They are intimately connected, and this is how. So as you know, Phi is this number 1.618. That goes on forever like pi, but makes a nice little number here as 1.618. And ultimately is going to create this sequence. Both of them create this sequence, a plus b equals c. But they get there in two different ways. So phi assumes a given number, a, and then you multiply or divide a by phi, and that creates b. And that's how you get a and b. And from a and b, you get c. So that's always going to stay this phi relationship. Fibonacci, on the other hand, basically does a plus b equals c right off the bat. But it doesn't know about the phi ratio, so it has to do something different. So it basically just mirrors itself. It adds itself to itself, and that creates a new thing. So 1 plus 1 equals 2. And then 1 plus 2 equals 3. And then 2 plus 3 equals 5, and so on. So it's always a plus b equals c, but it starts with doubling up the first number as opposed to using this ratio. In part because this ratio doesn't actually exist anywhere, so if you didn't know it, there'd be no way to get it. Whereas the only thing you can really know is yourself, and so you have to just mirror. You grow through mirroring yourself, I guess. I don't know. In doing so, it creates this odd, even sequence. And I believe that carries on through the whole number. Correct me if I'm wrong. So, as you can see, that is not phi. So what's happened here is a has doubled up with a to create b. So that means that green area, that void space is the same as a, whereas here the void space is just a pure phi. And this rectangle is pure phi, and it fractals in of itself beautifully forever. But this one does not do that. However, this relationship of a and a is different than this relationship of a and b. So c is the conclusion of a plus b, whereas b was the conclusion of a plus a. And that's the same as it's this. So it's not phi, but it's also a changing ratio. So it's not a consistent ratio. That's the problem with Fibonacci. Phi is a consistent ratio. So you can just easily multiply or divide any number and you'll get a phi scale. Fibonacci is not so simple. If you have a number, you got to go through this whole sequence before you find the ratio that it's eventually going to level out at, which of course is phi, which is why we use phi just to skip ahead, and it's much easier for calculation. So here you can see a little phi sequence. So it goes 1, 1.618, 2.618, 4.236, and that's all just multiples of phi. You just multiply 1 by phi, and it will give you this sequence on forever, and in fact goes the other way too, down forever. Which is another point about phi, is that it always extends in both directions infinitely. Theoretically, Fibonacci does also, but not really. Fibonacci has an actual starting point, which is another reason why nature likes it. So it's whole numbers and it has a beginning, whereas phi doesn't necessarily have a beginning. It just exists always everywhere, whereas Fibonacci has a beginning. So that's a very important point in terms of nature. It has a beginning and it uses whole numbers. As you can't have a fraction of a leaf, you can only have a whole leaf. Things only exist as wholes in physical reality. So if we track that ratio, we can see that 1 to 1 is 1 multiplied by 1 equals 1. 1 multiplied by 2 equals 2. 2 multiplied by 1.5 equals 3. 3 multiplied by 1.66666 equals 5, and so on. So when you map that on a grid, you can see that the phi line creates this constant baseline, whereas the Fibonacci line oscillates above and below. And I believe it always oscillates above and below. I don't think it ever actually gets there. For all intents and purposes, it achieves it basically right here. I mean, 34 and 21 are so close that it essentially has achieved it already in a couple of steps. So that takes about 1, 2, 3, 4, 5, 6. So you can say the 7th and 8th step, by the time it gets to 9, it's basically in sync with phi. And then the distances between these two numbers, 21 and 34, if you just kind of, well, basically if you just move them, they will line up with these numbers eventually. If you scale them together, they end up being the same distance because they do the same thing. And that is why, as a mapping exercise, it's a lot easier just to simply use phi. It's a golden rule. We know it's a mathematical purity, and it is just simply easier to work with, even though, in truth, nature uses Fibonacci. But that's because it doesn't know the phi ratio, I guess, even though it does, and that's where it comes from. Weird. Thank you very much. Hope that was somewhat helpful, and hopefully you'll check out some of my other videos. It's a cool, cool world. Take care. Be safe out there. See you later.